And now we are going into the topic, now we are going to learn about who is, why a name called as your Boolean algebra has been given, and who is the early learner of this Boolean algebra is called as your George Boole, and he is the father of the Boolean algebra because he is the one who had given the basic operation ideas of your AND gate, OR gate, and AND, OR, and NOT operations. Your AND operation is the multiplication of the bits, OR operation is addition of the bits, and NOT operation is just an inversion. Okay, Bool system. Okay, Bool system, he had detailed in a book called as an Investigations on the Law of Thoughts, on which are founded the mathematical theories of logics and probabilities in 1854. See, this Boolean algebra, we think that it's in simple, for it can be used for simple mathematical problems and solving mathematical problems, but whereas this concept of this Boolean algebra has has paved the path for many founding research findings under your light and as well as your matter aspect is about. So was based on the binary approach, processing only two objects, the yes or no, true or false, on or off, 0 and 1 approach. So for example, when on our household appliances, when a switch is in on condition, we can say that it's on 1 condition. Okay, when the switch is in off condition, we can say that in as Boolean, we can say that it is an at 0 level. Okay, level can be estimated with help of using the Boolean algebra. And next one is your axiomatic definition of your Boolean algebra. We need to define the algebra for binary values developed by George Boole in 1854. That Huntington, okay, postulates for Boolean algebra, which was given in your 1904. Okay, so the concept of your Boolean algebra was developed in 1854, but whereas Huntington have given some postulates for the Boolean algebra in 1904. That is the Boolean algebra, that we are having two logics, one is called as your 0 and 1 logics, and two basic operations, one is called as your positive and as well as your multiplication operation, that is your addition and multiplication operation. Closure with respect to the operator plus and operator dot, and identity element 0 for operator plus and 1 for the operator dot, and commutative with respect to your plus and as well as your dot. Yeah, so you can write as x plus y, that is equal to your y plus x, and x into y which is equal to your y into x. Distributive of, okay, multiplication over plus and plus over the multiplication. So you could write as x into y plus z which is equal to x into y plus x into z. Okay, and x into y into z is called as your x plus y into your x plus z. There are two elements x comma y which should be in the binary operation, okay, which is given in the binary value which is called as your b, such that x is not equal to y. Okay, at no time 0 can be equal to 1, 0 is always not equal to 1 only. Complement of every element is x is x slash, okay, x bar, okay, and with x plus x slash is equal to 1 and x into x slash is equal to 0. We have studied this. This is called as your inverse axiom. When on a positive operation, when a number is added with its inverse, the value should be an identity element. The identity element of the addition operation is your 1, and when you multiply with when you multiply an element with its inverse, so x into x inverse, okay, x into x inverse should be result in an identity element of the multiplication. The identity element of the multiplication is your 0. Okay, Boolean algebra, how we can use the terminology is, the terminologies are three terminologies. One is called as your literal term, and next one is your product term, and next one is your sum term. Literal term is a variable or its complement, okay, a variable or its complement, and a product term is literals connected by, when the literals connected by your dot, then it's called as your literals connected by the dot is called as your product term. When the literals are connected by, okay, connected by your positive, it's called as your sum term. Literal means it's a variable or component. Product means it should be there should be a multiplication symbol in between. Sum means there should be a positive symbol in between. Okay, postulates of the two valued Boolean algebra are, for example, binary values are 0, 1, and two binary operations plus and dot. The rules of operation are or and not. We already know that x, y, x into y. So 0 into 0 is your 0, 0 into 1 is your 0, and 1 into 0 is your 0, and 1 into 1 is called as your 1. For OR operation, it could be 0 plus 0 is your 0, 0 plus 1 is called as your 1, and 1 plus 1 is called as your 1, and this 1 plus 1 is called as your 1 0, where that 1 is the carry. That 1 you take it as an end around carry and you add it with the sum bit. For example, 1 plus 1 is equal to 1 0 is your answer. Okay, that 1 is called as a carry. That carry is to be added with the sum bit of 0, so that 0 plus 1 will result in your 1 only. But whereas for NOT operation, x and x bar, x is your input, x bar is your output. So when you take x as 0, the x bar should be 1, and when you take x to be 1, and your x bar should be equal to 0. So now we are going to verify with your closure and identity axioms. So for closure axiom, we are going to take the positive and as well as your multiplication operation. The identity elements are for positive, for addition the identity element is your 0, for multiplication the identity element is your 1. And now the postulates of the two valued are the other two laws are, one is your commutative law, next one is your distributive law. Say for example, your commutative and distributive law could be better learned by using this. So you could write as x, y and z be your three values. When the number of inputs is 3, then the possible outcomes of your x, y and z is 2 power of your n outcomes. Okay, that is when number of inputs is n, your possible outcomes is 2 power of your n. Here the number of inputs n is equal to 3, so the possible outcomes will be 2 power of your 3. The 2 power of your 3 means it's called as your 8. So it may start from 0 0 0 to 1 1 1. Okay, now what you can do is, for this commutative axiom and distributive axiom and all, commutative axiom means x plus y plus z is equal to z plus y plus x. Okay, that is called as a commutative axiom. But whereas as of your distributive law is about, what we are going to do is, for example, x dot of y plus z is equal to x dot of y plus x dot of z. This is called as your distributive law. How that could be estimated is, so x dot of y plus z. So first you find your y plus z. Y plus z means you have to add these two values. 0 plus 0 is your 0, and 0 plus 1 is your 1. 1 plus 0 is your 1, and here 1 plus 1 is called as your 1. Again 1 0 it will come. Then that 1 will get added with the 0. That is your end around carry. So we can make it as your 1 plus 1 is also 1, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and again this 1 plus 1 is called as your 1 only. So x into y plus z means now you want to find an AND operation between the x and y plus z. Okay, x and y plus z. So 0 into 0 is called as your 0, 0 into 1 is called as your 0. Okay, and next one, 0 into 1 is called as your 0, 0 into 1 is called as your 0, 1 into 0 is 0, 1 into 1 is 1, and 1 into 1 is your 1, and 1 into 1 is again 1. That means your answer will be 0 0 0 0 0 1 1 1 is your answer of your x into y plus z. Now what you want to do is, by distributive law, x dot of y plus z can be given as your x dot of y plus x dot of z. Now what you do is, you find x dot of y and as well as your x dot of z. Okay, you have to find the multiplication rule. Okay, dot operation between the x dot of z and as well as your x dot of y. When you find that and when you add both, you will be getting, it is resemble that the red column and as well as the blue column are one and the same, so such that it proves the distributive law. Okay, and the next one is called as your next postulate of the two valued binary Boolean algebra is your complement rule. When it is operated, when an element is operated by an addition operation, okay, the sum of the element plus its inverse should be equal to your identity element. So here you see here x bar is the inverse of this x, so x plus x bar should be equal to your 1, where 1 is called as your identity element. Okay, so for example, 0 plus 0 plus 0 bar, 0 plus 0 bar means 0 plus 0 bar means 0 bar is nothing but your not of your 0, not of your 0. When you take not operation for this 0, the value is equal to 1. So 0 plus 1 it will come. 0 plus 1 is equal to 1. For addition operation, the sum of the element plus its inverse should be equal to 1. So see here, 0 and its inverse 1, when they both get added, your value is equal to 1. For example, instead when you go with 1 plus 1 bar means the value is 0. So 1 plus 0 which is equal to 1. So the identity element you will get when a number is added with its inverse on addition, under addition operation. Okay, so your identity element 1 will get replenished. Okay, but whereas here when a number is multiplied with its inverse means your value that you will get is called as your identity element is your 0. So x into x bar is called as your 0, and 0 into 0 bar is your 0, and so for example 0 into 0 bar is equal to 0 bar means it's called as your 1. So 0 into 1 which is equal to 0 into 1 is called as your 0. But whereas the same 1 into 1 bar, okay, 1 into 1 bar which is equal to your 1 into this 1 bar could be written as your 0 here, 1 into 1 bar is your which is equal to 1 into 0 which is equal to your 0. This has two distinct elements 1 and 0, okay, where at no time 0 will be equivalent to 1, okay, 0 is always not equal to 1, okay. So note is a set of two elements, okay, it should have a set of two elements. One is your plus is your OR operation and dot is your AND operation. A complement operator is called as your NOT operation. Binary logic is always a two-valued Boolean algebra. And the next thing we have to study is called as your duality principle. The principle of duality is an important aspect. This says that if an expression is valid in Boolean algebra, the dual of that expression is also valid. How to create a dual principle is, how to create a duality is, see, this I think you would have studied in your level of your first year circuit analysis. You would have studied, you would have drawn on a circuits using the dual principle, okay. In a dual principle, a resistance will be converted into one conductance, an inductor will be converted into one capacitor, a capacitor will be converted into an inductor, a voltage source will be converted into one current source, and the open switch will be converted into one closed switch, like that. Vice versa, opposite. So here duality we are going to study between two things. One is called as your multiplication operator and as well as your positive operator. Here what duality means is, okay, on a expression, okay, expression which has finalized and which has proved all the postulates, all the 6 postulates as we have termed earlier, the dual of the expression. For example, dual expression means, for they have given a logical expression as something as so x plus, okay, for example, you see here from the form the dual of the expression. So for example, a plus of your bc is the expression that has been given. How to convert a dual is, so see here, between b and c you are having a multiplication operation. Between a plus of your bc means here you are having a multiplication operation. What it is stated is, to form a dual of an expression, replace all the positive operators with dot operators and all dot operators with positive operators, all ones with zeros and all zeros with 1. This is called as the duality principle. This is called as your duality principle is, okay. So this is what, okay, so form the dual of the expression means this is the expression that has been given as a plus of your bc which is equal to a plus b into your a plus c. Now you by you following this principle, you can do this operation as this plus is to be converted to dot, then this dot is to be converted to plus. So a of your b plus c which is equal to this. Now here the plus is converted to dot, so ab, and here this plus is converted into your dot, so ac. Between that you are having a multiplication operator that is converted as a positive. Take care not to alter the location of the parenthesis. You at no point you should alter the location of the parenthesis. Only what you have to do is, for a set of equation, you can just change the positive to negative and negative to positive. You don't have the rights to change the parenthesis position. And I think we have completed with the first part 1 of this video, and thanks for listening, and we will check out with the part 2